Okay, number 1, use summation notation and evaluate the series. So there's a couple things going on. When I do summation notation, I want to write n equals 1, but I have to figure out the explicit formula and write it right here, and I have to figure out how many terms there are. So, first of all, this is an arithmetic sequence, just because I'm going up by 5. So I'm going to use the arithmetic sequence formula. So it's going to be a sub n equals a sub 1 plus n minus 1 times the common difference. So I'm going to plug in, I know the last term, or the nth term, is 314, and I'm trying to figure out how many terms there are. So the first term is 4 plus n minus 1, and my common difference is 5. So what I do is I need to solve for n. So I'm going to subtract 4 and then divide by 5 and then add 1 at the end, so I get n equals 63. So there are 63 terms. So I need that in order to write this in summation notation. Okay. I also want to have this because I want to write my explicit formula for my arithmetic sequence right here. So I'm going to take this, write a sub n. So a sub n equals 4 plus n minus 1 times 5. So this is going to be a sub n equals 4 plus 5n minus 5. So that simplifies to be 5n minus 1. So this is the summation sigma notation. Okay, then I want to evaluate the series. So it's important to know what evaluate the series means. It means you're going to add up all the terms of the sequence. So I'm not going to do that if I have 63 terms. So I'm going to use the the arithmetic series formula, which is the sum of the first 63 terms of the sequence is the number of terms divided by 2 times the first term, which is 4, plus the 63rd term or last term in your sequence. So the sum of that is 10,017. It's a pretty loaded problem for problem number 1 because you had to do a lot of things. You had to know how to write the summation notation. You have to figure out how many terms there are by using the explicit formula. You had to write the explicit formula right here, and you had to sum up the sequence or find the series. Okay, number 2, find the missing terms in the arithmetic sequence. So what you're going to do is you're going to figure out this one, you need to average out 98 plus 50 and divide it by 2 and get 74. Then you're going to take the average of these two. 50 plus 74 divided by 2 is 62. Then you're going to add up 74 plus 98 divided by 2 and get 86. Number 3, find the missing terms in the geometric sequence. So to do that, you do the square root of 12 times 24. Okay, so I'm going to break that down. This is the square root of 12 times 2, which is 12 root 2. That's the quickest way to break it down. So this is going to be plus or minus 12 root 2. So the reason it's plus or minus is because we don't know if the common ratio is positive or negative. It could go positive, 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 or it could go positive, negative, positive. We're not sure, so we have to put plus or minus right here. Okay, number 4, write the related series and evaluate the series. So to write the related series, what that means is it doesn't read whether it's summation notation or not, so I'm just going to write it out that it needs to add them. So it means add negative 6 plus negative 9 plus, negative 9, negative 6 plus negative 9 plus negative 12 plus negative 15 plus negative 18, all the way to adding negative 213. That means writing the related series. Evaluate the series means give me the answer to what that would be if you added all those numbers up. So again, I don't know the number of numbers. So I'm going to take my explicit formula, which is going to be a sub n equals a sub 1 plus n minus 1 times d. And I want to do that because I want to figure out what n is. So the last term, or the nth term, is negative 213. The first term is negative 6. And now I want to, and the common difference is negative 3. So now I need to solve for n. So I'm going to add 6 over here. And then I'm going to divide by negative 3. And then at the end I'm going to add, so I get 70. And in the end I'm going to add 1, so, I get 69. So in the end I'm going to add 1, so n equals 70. So there are 70 terms in the sequence. So to evaluate the series, it's an arithmetic series. So I'm going to use the formula S of n, which is 70 terms, equals the number of terms over 2 times the first term, which is negative 6, plus the last term, which is negative 213. So when I add that, I get negative 7665. That's evaluating the series. This is writing the series. This is evaluating. Okay, number 4, write an explicit rule or an equation. Same thing, formula for the arithmetic sequence. So your first term is a sub 1, and your 32nd term is negative 165. So for an arithmetic sequence, we need to know what the a sub 1 is and the difference in order to write our formula. So right now I have the a1, I have the nth, because n is 32, and I have a sub 32, which is negative 165. So I'm going to plug this into the explicit formula. So I get a sub 32, which is negative 165, equals the first term, which is 15, plus n minus 1, we know n is 32, minus 1, times d. So I'm solving for the difference right here. So when I subtract 15, so I get negative 180 equals 31d. So d is negative 180 divided by 31. So my explicit formula or rule is going to be a sub n equals the first term, which is 15, plus n minus 1 times d, which is negative 180 over 31. Okay, then number 6, evaluate the series. So you can check whether it's arithmetic or geometric just by generating the first few terms. I can tell that it's arithmetic because it doesn't have an exponent. So this is going to be, the first term is going to be, plug in 1 is 7. The next term, plug in 2, is going to be 12. The next term, plug in 3, is going to be 5 times 3 plus 2 is 17, etc. All the way up to the 15th term. So this is an arithmetic sequence, so I'm going to use this is an arithmetic series because we're summing the sequence. So I'm going to use the 15th, sum of the first 15 terms, because it's 15 minus 1 plus 1 gives you the number of terms, equals 15 over 2 times the first term, which is 7, plus the last term. So the last term you're going to get by plugging in, or the 15th term you're going to get in by plugging 15. So this is going to be 77. So adding these up gives me 630. Putting this into my calculator. Okay, number 7. Evaluate the geometric series. So it's geometric series. I need to check. We have 2 different types. Is it finite or infinite? Because there's a different formula for each one. These ellipses means it's infinite. So the infinite geometric series formula is a sub 1 over 1 minus r. So my first term is 2/3, and my r is doing 4/9 divided by 2/3. That's the same thing as doing 4/9 times 3/2. So that's also 2/3. So the denominator is going to be 1/3. So it's going to be 2/3 divided by 1/3. And then I'm going to do the reciprocal to cancel out this. So the answer is going to be 2. So evaluating means the answer is 2. It's converging to a number. The r is less than 1. All right, number 8, find the first 20 terms of the sequence. So this, because it has specified 20 terms, this is a finite geometric sequence formula. So the formula is a sub 1, 1 minus r to the n over 1 minus r. R is -2. So it's going to be my first term, which is -5 times 1 minus -2. Now I'm putting that in parentheses because it makes a difference with the power. To the 20th power over 1 minus -2. If you put this in your calculator, you should put parentheses around the numerator and denominator. So try it in your calculator and you should get 1,747,625. Okay, 1,747,625. Okay, number 9, find the first 20 terms of this sequence. So you have to evaluate this series. Well, this series is a arithmetic sequence. So you're going to use this formula. The sum of the first 20 is 20 over 2, the first term plus the 20th term. Okay, I don't know what the 20th term is, so I'm going to have to do a little bit more work on this. So to find the 20th term, I'm going to use the explicit formula. So it's 12 plus the common difference is 2. So it's going to be 20 minus 1 times 2. Because there's 20 terms, that's the n. So that's going to give me 50. So my last term is 50, or my 20th term is 50. So that gives me a total of 620. And then number 10, a theater has 30 seats in the first row. Each row behind the first gains 15 total, so it'd be 30. How many seats are there in the 15th row? So 30 plus 45 plus all the way to get to the 15th one. So I'm going to use the explicit formula, and that's going to give me 58. So 58 is going to be the 15th row. And then how many seats are there in the first 15 rows is you're going to want to use the sum of the first first 15 rows is going to be the number of terms, which is 15 over 2, times the first row plus the last row, which I got by doing the explicit formula. So you can plug that in. And then the last one, evaluate the series. So I can tell it's geometric because it has a exponent, or has a variable in the exponent. And this is finite because of the 25 right here. Okay, it doesn't have an infinity. So I'm going to use the formula of a sub 1 times 1 minus r to the n over 1 minus r. So the first term, if plugging in 3, is going to be -8. 1 minus, the common ratio is going to be -2. And then to figure out how many terms there are, I'm going to subtract 25 minus 3 and then add 2, so it's 23 to the 1 minus -2. So you want to put that in your calculator, and you get -2236964.